name is Vladimir Bacvanski. I'm Distinguished Architect at PayPal, and I will be your guide on the path from domains to platform architectures. We are going to see the path from software services to platforms, including the data, and the problems that data in such systems cause, resulting in the path from data lake to data swamp. We will explore the data friction and its causes, and then how we can address that in the platform data systems. So, looking into cloud-native architecture, the question is, what is the path that we follow in order to get to our systems? And the well-established and understood path is the path proposed by the domain-driven design. Into domain-driven design, you look into the area of your business, you identify what are the things that you have there, how do they behave, how do they relate to each other, and you create an ubiquitous language, resulting in a common understanding of the terms between the business and software developers. Such domains will result in things that have single, well-defined responsibilities, and we have the notion of bounded context, which is the boundary in which we are viewing our systems. That enables us to decompose larger domains into smaller units. When you follow domain-driven design, that naturally leads to identification of services with their APIs, with the services that are exposed, but also services that they use from other elements. The classic work in this space is the book on domain-driven design by Eric Evans, worth a read. Now, looking into the architectures for the systems in the cloud, we typically see that the services expose the APIs, and then internally they are realized with a set of components. And most of the texts on services will stop there. However, what is important is to recognize that services on their own today are relatively small units. And as you are designing your enterprise, you're looking for larger elements. And that these are platforms. In many ways, platforms are similar to services, but they have a much richer and deeper structure, and they are also exposing APIs in a similar way as services, but internally they may have a number of elements inside. And also what is interesting is that the platforms tend to build ecosystems. With ecosystems, we have that the platforms can collaborate with each other. So there is a connectivity between the elements. And this is interesting because platforms are typically owned by different organizations. And that enable you, for example, to build ecosystems of platforms that are supporting e-commerce, payments, sales, marketing, and other domains. There is a gravity. Well-defined platforms will attract customers and users and enable generation of value by exchange of value between the producers and the consumers. And finally, flow is something that defines how easy it is for the platform to create and exchange the value across the ecosystem. Now, looking into platforms and services, we typically see that the platform is implemented by a range of services that collaborate with each other. But platforms also include a variety of data stores. Typically, you have the operational data store, often a relational database, that is going to handle transactions. But then, at the same time, there is a need to expose functionalities for various analytical queries. And typically, there is a different store, optimized for this type of workloads, and often having very different schema. So the analytical store is also one part of the realization of the platform. And recently, you have the third part of data stores or data processing infrastructure, which is focusing on streaming. You have the data that is coming in and streams, gets processed on the fly, and then can exit the platform to be consumed by other elements in the system. So, modern platforms have all these three elements. Now, in many systems today, you have the vision and the organization that the platforms are creating data, and the transactional processing is happening on the platform. However, the analytical workloads are happening in a data lake. And the idea is great. You have various sources of data in the enterprise, passing the data into the data lake, and this is where the data can be offered to various consumers in the enterprise. However, when you look into data that is being sent by the platforms into this data lake, you typically see that the data sent by the platform is not always of the high quality. And the result of that is that the platforms send data of the poor quality. The data ends up in the data lake, and that causes some friction. And let's explore this friction in the enterprise. So the friction in this scenario is kind of quite interesting because it has both happy and unhappy parties. So when we look at the platforms are typically data producers for the data lake. And the data producer teams, and you can see that there are many of them. For each platform, you are going to have a team. They are sending this data into the data lake, and the data lake is typically designed and operated by the data team. So these are the engineers dealing with various data technologies. So the platforms are sending their data that land in this data lake. And then you have the users of this data. So data consumers will access the data from the data lake, and they may find, for example, that the data is poor. Customers with strange and illogical names, and the data consumer team, knowing that this data is coming from the data lake, talk to the data lake team, asking them to fix the data. However, the data team that owns the data lake has nothing to do with the source of data which originated by some other platform. And now we have a very interesting situation here. You have that in general, the platform data producers are happy. They take whatever data they have and they just send it into the data lake. The data consumers are not happy. They need to consume this data. They find the data is problematic. They go and seek for help at the data team. Now, the data team needs to deal with the quality problems which are caused by somebody else. And when you have an organization that is growing in size, which is growing in coverage, that is becoming a burden on the data team because they would now need to support all kinds of new problem domains which may have their own very special data models, which the data lake team is not comfortable and knowledgeable dealing with. And when you think about what is the cause of the problem, you will see that there is actually an artificial split. And here we see the data split. On the left-hand side, you can see the platform with its operational stores, and the operational data is stored in that area. In the model that we have seen, the platforms are dumping their data into the data lake, here represented on the right-hand side. And there we see the analytical data stored in that place. Now, what is happening is the data, both operational and analytic, all represent data in one problem area, in one domain, yet they are artificially split. And even worse, they are managed by two different teams. And this is causing friction. And the question is, when we want to combine these things, when we want to have a clear ownership of the data and aspire to the notion of data product with high quality, what are the things that we need to do? An approach to deal with this split ownership of platform data between the operational stores in the platform and analytical stores in the data lake is for platforms to embrace the notion of their data as the data product. That would mean that in addition to APIs, for which we understand that there are certain measures and service level agreements, the platforms need to expose the data with the same aspiration for quality and maturity as they do for the APIs. In the lower part of our platform, we see now that there are data pipelines that are receiving certain data, they can do transformations and processing of data, and then they can also expose this data to the consumers of the data. One thing that we also note here at the bottom part of the diagram, there are certain APIs, and these are the APIs related to platform data, usually around the monitoring, control, metadata, and more. So now in this model, the platforms expose not only their APIs, but also their data with the same aspiration for quality. And this is a big shift in comparison with traditional dealing with platforms and data. So the data product is the key element in this construct. How would this look like in an example? So we have on the left-hand side example of a customer. The customer exposes some data. Then we have the customer interactions, and we have the third-party file that contains additional details about the customer. And you can imagine that there is a marketing department that would love to combine the data about the customers with information, what are they doing on the website, and enrich that with some information from another party, and bring this all together and then provide the marketing recommendations. So here the marketing platform will access the data from customer interactions and so on, do the processing, and then provide the result as the marketing recommendation data. Now, imagine that the owners of the marketing platform recognize that there is a problem with the data they are getting from customer platform. For example, there is a customer called Mickey Mouse. In this model, the marketing platform owners, they can talk to the customer platform. Customer platform is subject matter expert for this area. They ingest the data, and it makes sense to move the quality requirements about this data to the owner of the platform, as opposed to delegate it to some third party like the owners of the data lake. So the marketing team has immediate connection to the platform team for the customer, and they can address the problems there where there is the most knowledge about an issue. Now, one of the interesting elements is how do marketing platform owners know where to go? And for that, we need to have a strong support with the data catalogs. We need to know where are things in the enterprise, and that needs to be searchable and always up to date. We'll see in a moment how are we going to deal with that. So the question that naturally comes, does this approach mean that each platform is going to reinvent their analytical data capabilities and that they're going to reinvent their policies and practices? The answer is no. So this model works well in the situation where we have the platforms that are producing and consuming data, but then for everything that is related to technical areas of processing this data, and they are using a data infrastructure platform. And considering that we are targeting some autonomy and ability to run the systems in the cloud, having this platform perform in a self-service way is very important. So the platform owners can access and use the capabilities that are provided by this infrastructure platform. And we want this layer to be common for the enterprise. And this would provide with capabilities to define and store files in the cloud, provide access to various relational stores, streaming data, other kinds of databases, and all kinds of data processing that would make sense. Now, here we need to be careful because in order to do this really productively, we need a couple of things that go beyond pure technology. And that is, there is a layer of things that we want to provide, which are the common services, from security, identifying privacy data, understanding where is privacy data in the whole enterprise, being able to provide for centralized governance, having knowledge about metadata about all of these sources, quality audit, and so on. So these are the capabilities that are defined by the centralized team. And what is interesting here is that the actual data ownership is decentralized and that the data belong to the platform, but the governance and the tooling and the self-service data platform is created in one place in the enterprise. And this is very important. So centrally governed services and individual ownership of data. And if you think about it, this is something that we could see in the other areas. For example, the APIs in a company. Typically, different platforms would own their own APIs. However, the governance, how this API should look like, what are the quality measures, what are the maturity measures for these APIs is defined centrally. This will require some shifts. One is a shift that we have already seen in industry, movement of software development processes towards DevOps, where we have the shift left, where the quality is moving to the left. And now there is something new, and that is that platform owners cannot just dump their data into the data lake with the hope somebody else will take care of it, but the platform owners need to have data skills. And all of that should be supported by reference architectures that are providing good examples and guidance. How do we want to develop such systems in the organization? There should be a layer of these data services that we have seen in the previous slide. And also you want to automate the processes and reduce the friction from this approach. And what is interesting is that with the right tooling, with the right systems that you introduce, you will actually enable system in which people behave in certain way and certain practices become norm, reduce friction, and improve the velocity of the team. So to summarize, we have the model in which platforms and their teams own both the operational and analytical data. There is a notion of data product, which has aspiration to high quality in the same way as the platform APIs. We are using the same infrastructure as we would do in the data lake. This is enabled especially well with the modern cloud technologies. Self-service data infrastructure platform, so the platform owners can use the capabilities in a productive way. And if you deploy this in the cloud, then you will have additional advantage of being able to be elastic and scale to the needs. One thing that is absolutely critical here is you must have governance that will span across the platforms. Finally, the question is this a ideal solution for everybody? And the answer is no. If your organization is small, your problem domain is small, you may be well served with the data team that understands all aspects of your business and actually manages the data for everybody. But if you are in a larger organization, or if you are onboarding new problem domains where the data teams don't have the necessary expertise in understanding and managing this data, or if you are acquiring company that are coming with their own data models and systems, then this model enables you to move fast, have the common governance, and accelerate the path from the data finally to combining this data and deriving insights from this. So with this, I wish you all the best in your data transformation journey. Thank you very much.